Good morning.
Hello, Negotiation. Oh, Ian, nice to see you.
How are you?
Ah, very fine. Nice to see you, Ian.
Yeah, middle of the night here, I'm afraid, notwithstanding the background.
I like your background. I wish I was there.
Yeah, we have many strange things. So it's we work magic here. We have even
There you go.
just to
Very
chase
impressive.
away the demons. They're always useful. You never know.
Dr. Neskovic, we don't hear you clearly. Could you please sign out and join again? It is so... Okay.
Anastasia, there you are.
Oh.
Check the name. Check the name you appear with. You are not Neborsa. Should change that. And you too, Ian. You appear with the name of another person.
Okay, how do we change
It's giving everybody that name, including the person himself.
Yeah.
herself.
Vasuki, do you hear me now?
rename? Here we go.
Yep.
Yes, you're clear, Nipash.
Rename. Okay, good.
Vasuki, do you hear me now?
Your audio is
Yes,
clear.
yes. It is clear now. Yes.
You hear me, okay?
Yeah, it is good
Okay,
now.
now it's better,
Very
much
good.
better.
Okay. Well, let us wait a few more minutes and then we'll start. It's not 1 o'clock yet. Is everybody with us? I see.
Yes, yes. Okay. Hi, hi.
I
I
get
think Anitra said to you, Ugo, that she's coming shortly, but she will not be very vocal because she's been having throat surgery or something like that.
Yeah, poor Anitra. But she said she will do her best. It's all right.
Yeah, she will try to answer questions if she can, and if not, I'm her standby.
but she has sent a very nice video. I think
Yes.
Yeah, who is going to set up the to set up the video? You, Nebojsa, you will show the video.
Okay, let us start, okay?
Mhm.
Hello, everybody. My name is Nebojsa Nešković. I'm Vice President of the World Academy of Art and Science. Welcome to the WAAS talks on science for human security, natural geoengineering methods for cooling the planet. In August 2023, the United Nations General Assembly proclaimed the International Decade of Sciences for Sustainable Development for 2024 to 2031. The task to lead the preparation and implementation of the activities within the decade was given to UNESCO. This will be going on in close cooperation with that organization and other relevant organizations within the UN system, with the Earth Humanity Coalition, which is an association of a few hundred international, regional, and national non-governmental organizations and private sector entities, as well as some governments. WAAS is one of these organizations. It has made the program for the decade as part of the overall program of the coalition. This webinar is the first event within this program. The moderator of the webinar will be Ugo Bardi from the University of Florence, Italy, and the speakers will be Anastasia Makaryeva from the Petersburg Nuclear Physics Institute, Russia, Ted Manning from the Tourist Company, Canada, Anitra Forhog from the Yale University, USA, Ian Dunlop from the National Centre for Climate Restoration, Australia, and Chayden Diab from the Industrial, Environmental and Sustainability Organization, France. Now, I'm asking Ugo to give us a brief introduction to the 5 talks. Ugo, please.
Yes. Thank you very much, Nebojsa. It's a pleasure to be here. It's a pleasure to start this seminar, which I think is very important, very interesting, and it approaches us a problem that we badly need to understand and to discuss, because the situation of Earth's climate is not good. As you all know, we are not really losing control, because maybe we never had control on this planet's climate, but we are trying to understand and possibly plan ahead to see what we can do to manage the climate in ways which will not create more damage than what we have already done to the system. So we, with the help of the World Academy of Arts and Science, and thanks very much to Nebojsa for having organized this seminar, we collected a few experts in biosystems, ecosystems, oceans, forests, and also something about the conventional, geoengineering. I would not say it traditional geoengineering, because there's nothing traditional in engineering. And I'm happy to have also Chayden, who will tell us something about the problem of how people, we humans, have to face this enormous problem. So I am not taking too much of your time, and I will introduce the speakers as they start the talk. And I would remember to the speakers, if you can keep your talk in between 10 to 15 minutes, it's not, it's okay, but try to concentrate what you want to say. And first of all, I'm happy to have Anastasia Makaryeva from the St. Petersburg Physics Institute, presently at the Technical University of Munich in Germany, who will tell us about how the system, the planetary systems, interacts with forests and with such concepts as how forests regulate climate. So Anastasia, thank you very much for being here, and I leave to you now the floor, but now there is no floor, but this is the way we say it. We leave the floor to you. Thank you.
Thank you very much, Uga. Can I share my screen? Yes.
Yes, please. Yeah.
So,
Good.
can I? It's okay. Okay. Thank you very much for inviting me to talk here. It is a great honor. I'm speaking from St. Petersburg in Russia, which my country is the country which has a lot of forests that we believe are drastically underappreciated in the climate change narrative. So I will try to tell you a story of why forests are very important. And probably this will provide maybe an unexpected perspective on how we view the climate change and the strategic and tactical solutions to the mitigation problem. So I will base my talk on the notion of climate sensitivity. And climate sensitivity is just how we expect, by how many degrees we expect the planet to warm if CO2 doubles. So it is a measure of response of the planet to CO2 increase. And now there is a problem in climate change science, which can be summarized as follows. Climate models that describe the present well, the cloud cover and everything, have a significantly higher climate sensitivity than models that describe the past well. So it seems that, so there is this problem and how this could be. And I will give you an idea of what the climate sensitivity is. Actually, it can be described as having 3 legs. This is a 3 legs narrative, is inspired by Rob Lewis' story on Milan's narrative of climate change, first having 2 sides, 2 legs, like land use and CO2, and now becoming 1 leg, more focused on CO2. So inspired by this vision, I will offer you like a brief view of the 3 legs of climate sensitivity. So you can see, imagine our atmosphere. So this is height. So this is like our atmosphere, and this is temperature. So we know this graph on the right shows how the actual temperature declines with height. Okay, and there is, our planet receives energy from the sun, and definitely it also emits almost as much as it receives, with a very high precision. Otherwise, we would be warming much faster than we do now. And so there is a layer in the atmosphere where those molecules sit that emit thermal radiation directly to space. This is the upper radiating layer, and it is about 5 kilometers. And then there is equilibrium temperature, the second leg, which determines how much the planet must emit to keep the balance. And then we know that there is a vertical temperature gradient, which actually is a measure of the greenhouse effect. And we know that our temperature is much higher than the equilibrium. It is about like 290 K. So what determines these 3 legs? The upper radiating layer is determined by the CO2 amount. I just tell you that you will play with all this as I will make my slides available. This is really a good way to understand how the climate change narrative is quantitatively like based. So there is the equilibrium temperature is determined by albedo, and the vertical gradient of temperature may be determined by natural forest, as I argue. So what happens when we increase CO2? Then these molecules that emit directly to space, when we increase CO2, they find themselves higher in the atmosphere, okay? So we had about 5. This is like not exact figures. Now, for example, we have 6, but the temperature there is lower, and so to match the incoming energy, we must have warming. So the surface must warm, and this is, you see, these lines are parallel, this goes up. This is the essence of CO2 related warming as it is currently incorporated in climate models. Then we can decrease albedo, which means that the Earth will absorb more energy. Albedo actually determines how much the Earth reflects solar radiation back to space. Okay, so if we decrease it, for example, making the Earth darker, then the even if we don't change the CO2, so you can see this gray line remains where it was, still we will see warming again, because the planet will need to warm at the surface to emit more energy. And so CO2 increase and albedo decrease or increase is something that I bet everybody has heard about. And here already, when we talk about albedo, we already see that forests can play a very significant role, and I highly recommend this study of Ellison, Pokorny, and Wild, just out in Global Change Biology, who basically put forward the idea that no matter how climate models are struggling with reproducing the cloud cover, just reasonable expectations would be that the more forests we have, the more evapotranspiration, the more condensation, and the more cloud formation, and clouds reflect sunlight, and so the planet cools. So with more forests, as the authors argue, this blue line, vertical blue line, would move to the left, and we would see cooling, okay? So these are these two legs. CO2 increase leading to warming, albedo decrease leading to warming also. But the third leg is the most mysterious one. It is the vertical temperature gradient. You can see that if we change the slope of this line, how fast does the temperature decline with height? We can have warming at constant concentrations of CO2 and constant albedo. Nothing changes, just the temperature gradient, but we have warming. And so we argued in this study with colleagues recently that basically forests are absolutely crucial for the determination of this lapse rate. Why? Because when forests transpire water, they capture a certain part of solar energy as latent heat, and then this latent heat goes from the surface up to the upper layers of the atmosphere, where it is released, and this smooths the vertical temperature gradient. Upon deforestation, this upward transport of heat and heat is continuous, and the vertical temperature gradient becomes sharper, as you can see in this picture. And actually, we showed that indeed climate models consistently underestimate changes in the vertical temperature gradient. You can see that study, but basically these dashed lines are models, and these colored things are observations. So you can see there is no match, and especially no match over land. So, and this can be related, I return to my first slide, to the increasing climate sensitivity. So why do models that describe the present well have a high sensitivity? Because the sensitivity might have been increasing, reflecting the decline in natural forests and other natural ecosystems. And you can see that primary forests and non-forest ecosystems experienced a dramatically decline, like about 30%, over the same period that CO2 increased by the same 40 or 50%. Okay? So, and why should we expect that this should impact climate sensitivity? We do know, since the pioneering study of Vladimir Vernadsky, that ecosystems do have a major climatic impact. They are major players recycling all substances that matter for our environment, okay? Water and carbon and everything else. But what is the nature of this impact? Is it chaotic, just, you know, one day one thing, another? No. It is very natural that natural ecosystems have evolved a stabilizing impact on their own environment. Ecosystems exist for dozens of millions of years, and if they were destabilizing their own environment, they wouldn't be able to exist for so long. Hence, their loss and replacement by our arbitrary collections of species should increase climate sensitivity and lead to greater climate destabilization. And conversely, preserving natural climate regulating forests, and don't believe anybody who will tell you that they don't exist, that the forests are dying. They are not. They are only being killed when we log and burn them. If we leave them as they are, they will probably outlive us also. So, my last, what to do? Simply stopping the ongoing destruction of the remaining global wilderness, including currently self-recovering ecosystems, like the proforestation concept, can slow down climate destabilization. And as our analysis of the vertical temperature gradient shows, the impact can be very substantial. And international protection of these ecosystems and ambitious investigations to understand them are absolutely key for preserving human identity, what we are worth as a species, and as a highly developed, ethically and intellectually competent society. So, to stabilize climate, we call for a global moratorium on logging in natural climate regulating forests. And we are proud that our call was recently supported by many American scientists who wrote in a letter to President Biden, also requesting this old moratorium on logging old growth forests. It is really urgent and efficient measure to prevent the worst from happening. Thank you very much.
Thanks so much, Anastasia. This is absolutely great. You are bringing some hope to us. And let me add to what you just said, that we cannot preserve the forests if we keep warring against each other, unfortunately. But that's something to do with being human, apparently. So that's for the forest, the land, and then I'm happy to give the floor to Ted, who will tell us something about the oceans. Ted is from the Tourist Company, and you are in Ottawa, right, Ted? Your microphone, Ted. Microphone. Ted, your microphone is off.
Yes, it's technically challenging. There we go. Yes, Hugo. I'm in Ottawa, Canada. I'm a geographer, and I'm also a social scientist. And I'm going to immediately build off of what Anastasia says, which is don't wreck it, try and keep it. And from that point, we'll then look at really how we can deal with, in this particular case, farmland, owned land in the ecumene, which will reinforce a lot of what Anastasia has said. Now, let me see if I can get to my next one. The biggest issue we have is that most of the ecumene, most of the inhabitable parts of the planet, with the exception of forests, are owned, and even many of the forests are too. It's much easier to keep the capacity you've got, and particularly in communities where it's already subdivided into different land uses, different management, different ownership. It gets much more difficult. And quite frankly, if I go and talk to the people in the field in India or the field in Canada, let me see if I can get the next one. I have a rough time convincing them to do carbon sequestration. In fact, 99% of them have never heard the word. And yet you're looking right here in the Okanagan Valley at one of the best planted places for carbon sequestration, because it is perennial, it is vines, they are not cut down every year, the roots stay in the soil, and they are one of the crops that we understand is much better at actually supporting carbon sequestration. The big issue is that these are owned properties, and they really are not about to do something that will harm their own product. So what we are then looking at is something that will make possible uses that are compatible with the principal use of the properties we now have. The fact is that growing of crops like sugar are about the worst you can do, because it is burned, it is cut every year, and you have to look at any of the systems that you're managing in a very holistic way. In the Nilgiri Hills, we have agave type things that actually are very good because they are not cut every year, they stabilize soils, and they are fully compatible with a better form of conservation. Unfortunately, other crops, like some of the biggest producers in the world, are things like rice. And it is one of the worst. And not only that, but it is very controversial over whether or not rice paddies and wetlands can be positive or negative in carbon sequestration. The main issue is that regeneration of what you had before is usually one of the best things to do. And we have ample evidence from many different cultivation ecosystems of which work and which don't in excessive detail. So I won't really talk to you about that today. There just isn't time. But we do have incredible amounts of data on a per hectare basis on the key crops, on which ones sequester the most over which periods, how long it takes for them to sequester, how long it takes in the case of forests in Canada to grow to the point where they are doing net sequestration. And also, as came in the previous presentation, the issues of when it comes down, when it is burned, and so forth, that are all factoring into the amount of sequestration that is indeed possible. And there's a big difference between daily sequestration and net sequestration over the life of the crop. And I just refer to those who are looking. There was an excellent presentation on just this subject in terms of sequestration for Canada about a month ago. And I noted at the bottom, it's a series of Zooms that we put on the Canadian Association for the Club of Rome every week. The big issue is, what ecosystems do you choose? Which ecosystems are in fact capable of being used for carbon sequestration? Not only that, but you can't really mess with something like a wetland without affecting what happens downstream. And as Anitra will tell you later, what comes in definitely affects what happens in the oceans and downstream. And they are part of a very holistic look at how ecosystems serve the planet. We're looking really at very small scale environmental engineering in most cases when we're talking about owned land, your own property, whether or not you have grass on your lawn. All of those, in fact, at least are measurable in terms of whether or not they have capacity for carbon sequestration or whether you have destroyed it. And one of the worst really has to do with cattle. That we know that to begin with, simple fodder is not a very good one. Whereas on the other hand, the agave and other crops on the permanent crops shown on the right on this slide in Mexico are very strong sequestering crops. They have strong roots. They are there for a very long period of time and they will sequester. Whereas in the West, showing in the Great Lakes system, we just produce grass to put through cows, and the moment the cows come into it, we know the net impact on carbon is definitely going to be negative. And we're saying a whole system approach is probably the only one we can use when we're assessing any of these in a realistic fashion. The owners have to buy in. They're not going to do something they're not paid for. And one of the biggest initiatives we've done for many years is to try and convince people that there is a very broad range of environmental functions that do have value, and to try and get people to build that value into their own decisions. And if the owner of these fields is not receiving some kind of benefits from doing things that allow sequestration to happen, it's not going to happen. We can't even make them keep the water from running off their fields into places it should not, unless we provide methods for rewarding that function. We're asking them to manage water as well as crops. We're asking them to manage tree cover instead of crops. And what are we paying them for? And that's a very big issue for the future if we're going to get people to buy into sequestration. Certain crops definitely are very good for sequestration. The bamboo forest is probably the strongest, fastest growing, and as long as you leave it for a while, going to do a great deal of sequestration. So are these vines on the west, on the left, and the Christophine fields in Trinidad. Again, they're permanently, you're taking crops off them. They are controlling erosion, and they are also sequestering carbon fairly effectively. The fact is that olives, nuts, for those crops, they're there permanently. They are able to act as sequestration very much as trees do. And because they're there for a long period of time, they are sequestering for a long period of time. You're not digging it up and throwing it out on a regular basis. So to conclude, there are success stories. They are found around the world. They are working better from our studies so far, definitely in rainforests and in tropical areas, simply because there's a great deal more energy, a deal more transfer of energy and of nutrients. And the main key is to value sequestration and to create ways to pay for it. And just the last thing from where I work a lot is with the travel industry globally. And we are successful in extracting money from them to preserve things like the rainforest on the left that you see in this picture, because they see it as part of their doing business. They want something to show people and they want to make money from it. So thank you very much. We have a social system to try and change as well as a biophysical one. Thank you.
Thanks a lot, Ted. That was extremely interesting too. And we keep moving. You see that we have many possibilities to do good things. And the next one will be Anitra, but with a problem. Anitra, by the way, is one of the world best known world experts on marine ecosystems. She is in Miami, Florida. So she's not so well today. So she sent to us clip that we can show. Nebojša, can you show the clip, or Ted? Okay.
I'm going to talk about capturing carbon by blue carbon habitat in the oceans. And I have two other colleagues, Graham Berlin and Arthur Schwartz, who have done this work with me. First of all, when fossil fuel is metabolized, burned, it goes into the air, but then a portion of it is stored in the ocean. And that's on a gas exchange basis that it enters the ocean, which you see here in this illustration in green. There are ways the ocean pushes this around by upwelling, biological cycles, mixed layer dynamics, but basically 30 to 68%, and this is very disputed, of the carbon dioxide goes into the ocean. Where does the excess go? It goes into what you see here as blue areas, the Antarctic and the Arctic area. That's where it goes, enters the ocean particularly as carbon dioxide rich water, and it goes deep under the ocean and then upwells in what is called the equatorial current. This is the Pacific equatorial current, which is blown by Coriolis forces over to the Asian continent and goes through the through flow into the Indian Ocean. And in the Atlantic, there is an Atlantic equatorial current running along the northeast of South America, going into the Caribbean Sea, and then the Gulf of Mexico. Once it hits the shallow water, the major plant system habitat take up this dissolved carbon dioxide. And here you see seagrasses, which take up the carbon dioxide and extrude a good part of it through their root system down into the sediment below. Another portion is made into blades, which then decay after 30 days and metabolize, and small fungi and bacteria break them apart and they go into the sediment and are stored. Additionally, animals eat the blades and export them. This is the growing seasons, and in the red, which this is the Pacific tropics, the red is tropics, and the orange is subtropics. So here you have subtropics going into the Gulf of Mexico, and the yellow is the edge of the subtropics. So you see that the Mediterranean Sea and the Central Atlantic is yellow, but this part of the Pacific is bright red. This is where the growing seasons are very short and where the major amount of carbon is metabolized into the plants and stored into the root system and sediments. Here I'm showing you a picture of the seagrass of the world. And you notice that here in Southeast Asia, just south of Vietnam and Thailand, so forth, and Northern Australia, is a very large and important area. And this is the area that has 4 to 5 times more sequestration going on than some other areas like the Gulf of Mexico and Caribbean Sea, and like the Indian Ocean. To the right is the red box blown up, and what you see are not the seagrass, but the mangroves. So all these green edges are the mangrove population, and this is 6 million kilometers square of mangroves, the richest mangrove area in the world in Southeast Asia, where a great deal of carbon sequestration and capture occurs. In the tropical parts, which I have just shown you on the other map with red and yellow, it occurs for 12 months a year. In the temperate zones, it occurs for 5 months a year. And in the boreal zones, photosynthesis and carbon capture happens about 3 months a year. So if you would like to get the most cost efficiency, you would go into the tropical areas and regenerate as much blue carbon habitat as you can. And this is what I'm suggesting. The next slide shows the Marshall Plan that we have devised. And it's the cost is 355 billion over 7 years, which when you think of what France and some other middle-sized countries spend on their military per year, this is not so much out of kilter. It is about 52 billion a year, 52 billion a year. And this is to regenerate mangroves, corals, seagrass, temperate forests, tropical forests, and boreal tundra. Now, you must realize that the forests of the world have only 15% of their original extent still extant, and most of them are in Canada, Russia, Alaska, and Brazilian tropical forests, Cameroon and Republic of Congo forests, and Southeast Asia forests. And there's just a little in the temperate zone. So that's where the 15% of the remaining forests are. But the oceans have lost 70% of their natural habitat coastlines. So that's why we are particularly zoning in on the mangrove, where we would like to restore 50,000 kilometers square, the corals 50,000, seagrass 50,000, and these metabolize 12 months a year. So a great deal of carbon is taken in. Whereas for forests, tropical forests would be 35,000 kilometers, temperate forests 35,000, and boreal tundra and forest 20,000. We have tried as an attempt for the next question I know is in your mind, how much carbon will that totally capture? And it's a complex question because the science of oceanographic carbon sequestration is in its very infancy, really only about 6 to 8 years old. But we have, the team I showed you has looked at the Gulf of Mexico, where between the mangroves and the seagrass, which are about 1.6 million kilometers square, they have in teragram of organic carbon, they have about 400 teragrams, whereas the Caribbean Sea itself has about 1,200 teragrams, or 3 times more, even though it has just about 3 times more extent. But Southeast Asia has almost 12,000 kilometers square, and they have 4,700 teragrams of organic carbon that they have put as our first estimate We are still working on the Indian Ocean, and we do not have that estimate yet. But you can see that working on the Caribbean Sea, the Gulf of Mexico, and Southeast Asia could be a large win. The best part about these places is that labor is very low, and there are a lot of villagers, and there are a lot of people who would like very much to participate in this. And there are many scientists in these developing countries who also could be very helpful in developing. So this is what I have to say as a new way of capturing carbon and a new way of storing it. And remember, this is where the fossil fuel comes from in the beginning. That's why you put a pipe down and have oil wells that pump it out from Texas, from Saudi Arabia, from Kuwait, and other places. This is exactly how nature did it in the beginning. Thank you very much.
Thanks a lot. Anitra, I hope you will be able to be with us for the question and answer session. And now we move a little bit into a different field, and we would like to also know something about a more conventional way of doing geoengineering. And I would now have Ian Dunlop, member of the Club of Rome and of a member of the Climate Restoration Project. No, what is it? I forgot what the name of your institute, Ian, but it doesn't matter. From Australia, Ian Dunlop.
Okay, thank you very much, Ugo, and it's the Blue Cooling Initiative.
Okay, the blue cooling
So
also.
I might share my screen if I may. Okay. If everybody can see that.
Yeah,
Okay.
it is clear. Yes, please go ahead.
Very good. Okay, well, what I'd like to talk about is a geoengineering technique called marine cloud brightening. And of course, geoengineering has a somewhat dubious reputation. A lot of people are very skeptical that we should actually do any of it, except for the fact we have been doing it for the last, I don't know how many 100 years, as humanity has developed, but particularly since the Industrial Revolution, in using fossil fuels, of course. So what I will talk about is, firstly, just very quickly, why we have to move to this at this point. And as you may be aware, 2023 saw some pretty dramatic changes in climate change. We've, I would argue, moved into a new era. It's the first year where we have actually hit 1.5 degrees C warming relative to pre-industrial. The second half of 2023 was actually 1.67 degrees C, and September broke the record by about half a degree C. Now, 1 year is not a trend, of course, but the evidence seems to be that the Earth energy imbalance is such that we are probably going to see another hot year in 2024, and it is quite likely that that trend does actually continue. We've seen dramatically changed impacts in terms of heat, storms and floods. The graph there shows things that have taken scientists completely by surprise in terms of global sea surface temperatures. The orange line there is what happened in 2023 relative to decades beforehand. And 2024 is the black line at the top left-hand corner, which is not looking good, to put it mildly. We've seen other major changes that I won't go into, such as the Antarctic and so on. And one of the big concerns now is that the so-called climate tipping points, where you move from a relatively gradual change in climate to a non-linear, potentially exponential change from one steady state to another, may have been passed in a number of the key areas. I won't dwell on climate change tipping points now, but happy to talk about it in the in the discussion. The upshot of that, in the view of myself and my colleagues, is that humanity is now in very big trouble, because we're now facing the reality that the danger of irreversible runaway climate change is multiplying fast. This means that we've got to see carbon emissions, and not just emissions, but atmospheric carbon concentrations reduce extremely rapidly. And we have achieved precisely nothing in that regard, unfortunately, after 40 years of discussion. If you look at the fundamentals, our leaders have failed in that very fundamental issue of understanding what climate risk really means. This is one of the latest pictures of what is going to happen if you take current government commitments and industry commitments. We're likely to see emissions in the same position by 2050 as they are today, when we should see them dropping dramatically. So we haven't woken up. We're basically on a path toward 3 to 4 degrees C, and much above 3 degrees C is pretty unsustainable or survivable in many parts of the world, including significant parts of this country, Australia. So we have a very major problem that people have just not woken up to. And of course, we're compounding the problem by initiating conflicts all around the world at this point, which is not helping, because that is adding immeasurably to carbon emissions and preventing us getting on with the job of reducing them. So we have to take emergency precautionary action, in our view. This is a schematic representation. That is the current path, the black line. The dotted line is the danger level for cascading tipping point impacts and the so-called hot as Earth phenomenon, where we may get irreversible warming taking place. We have to get off that path, which means we've got to get emissions down as fast as possible. We have to also draw down carbon from the atmosphere, which is rarely talked about in all of these discussions we have at COPs and what have you. So we have to have a drawdown, something like that. But this is not going to be good enough, because we are already going to exceed 1.5 degrees. We're probably already there pretty much, and we'll be extremely lucky to avoid not going over 2 degrees C, which means we have to then pull down temperature after that has occurred, overshoot, if you like, and pulling down afterwards. To achieve that, we have to have some form of active cooling, which is going to cool parts of the planet to buy ourselves time whilst these other changes are taking place, the sort of things that Ted and Anita have talked about, in being implemented extremely quickly, if we can do it. So that is the objective of this active cooling process, is to give us time to achieve these further effects. So if you look at the sorts of things we're talking about here, I've just listed here on the left the potential drawdown arenas. I won't go through all of these in great detail, given the shortage of time. And on the right-hand side, the cooling effects you could look at. And marine cloud brightening is what I wanted to talk about today, as this is one of the potentially less damaging or less risky approaches to geoengineering to achieve that active cooling. There are various what one might term solar climate intervention methods. Item 1 here is surface albedo enhancement. In other words, increasing the amount of reflective ice or whatever, if we could do it. The second one is increasing the reflectivity of marine clouds, which is marine cloud brightening. The third might be putting stratospheric aerosols into the atmosphere to reflect radiation. The fourth might be putting some sort of space-based mirrors and so on in place, which obviously has major engineering issues. And the fifth is sort of decreasing the amount of high altitude cirrus clouds. This is just some of the things that people have talked about, but I'll concentrate just here on the marine cloud brightening aspect of it. The principle is fairly straightforward. Essentially, if you have high clouds, they essentially trap more heat. If you can create lower clouds, they reflect more sunlight. And clouds get whiter, essentially, it's been discovered by adding nanoparticles, essentially from sea spray. So the technique is essentially to work on that. Now, it was noticed, I think, back in the 70s that cloud condensation nuclei were formed from ships' chimney exhaust, created smaller cloud droplets and resulted in whiter clouds from shipping traveling around the world at that point in time. It was proposed then in the 1990s by John Latham that if you use sea salt nanoparticles to form that nuclei to reduce marine cloud droplets, you would then end up with having whiter clouds. And that's a fairly simple process that you see there. So if you look at marine cloud brightening in a nutshell, what it's doing is creating a sea spray of sea salt nanoparticles at the marine boundary layer below existing clouds, about 0 to about 1.5 kilometers. Those nanoparticles are uplifted into the clouds by natural turbulence. The nanoparticles act as a natural nuclear formation, and they reduce the cloud droplet size. So the smaller droplets, if you can create them, are essentially whiter, and whiter clouds reflect more sunlight, which gives you essentially greater albedo and hence the cooling effect through the atmosphere. So the process of doing this is firstly, from a laboratory point of view, to generate the right sort of aerosols in a nano sort of aerosol generation process, to then try out single plume studies from ships and so on in a marine environment, and then lead into multiple plume studies to prove up the process. The history of this so far is that this has been largely, entirely laboratory and desktop studies, apart from work that has been done in Australia, where we have the Great Barrier Reef, which you may know has been subject to considerable problems because of very high sea surface temperatures in recent time, where we have major bleaching events, and there are now dangers that coral reefs generally, certainly in the tropical zones, are under threat of extinction because of the sea temperature increase we're already seeing. So groups at Southern Cross University here have been trialing this technique in practice on a limited scale. It was first tried in 2021. The general indications are that it might perform better than the models predict. And it was demonstrated you could actually get the nanoparticles from the sea spray into the cloud formations. So why is it that we consider that marine cloud brightening is the best option? Well, I've just put up 3 options here, geoengineering options that have been talked about. It's a space shield approach, stratospheric aerosol injection, and marine cloud brightening. I won't go through all of this, but the marine cloud brightening essentially allows small trials to be carried out already. You are sort of mimicking the natural sea spray events. Pardon me. It's mild cloud engineering. It has the advantage that you can switch it on and off. If it's discovered there are problems with this, you can turn it off and the effects disappear very quickly. You can do it in a localized sense, but it has impacts globally. It can be developed very quickly, and as you can see from the comments I made earlier, we have a very limited time in which to make some of these things work. So it has the attraction that it could be available within 5 years. In fact, we really do need to see it far sooner than that if we could possibly do it. And because of its, I suppose, more natural approach than the other types of techniques, the societal acceptance of this is likely to be far greater. So those are the sort of advantage of the whole process. And we have an initiative called the Blue Cooling Initiative, which is aiming essentially at trying to get this up and running as a matter of urgency. So the critical message in all of this and the actions we need to take is that we have got to get to zero emissions at emergency speed. The whole idea of net zero by 2050, which is what the world is largely working to in official sense, frankly, is complete nonsense. We have to achieve this far more rapidly. The Earth is already too hot, as we've seen, so we have to have large-scale drawdown. The damage is going to continue to become far worse before long-term solutions are effective, so we have to have a safe means of immediate cooling. So this process of produce, remove, reflect, and repair is the framing that I think we're using. The Blue Cooling Initiative itself, I won't spend a lot of time on this, but you can see it on the website, is set up to try and do all this within sound governance principles. And we're currently in the process of trying to find funding to initiate the principle. There are a number of universities involved in Europe, in Australia, and in the US. So I think I might leave it at that, and we can talk more detail in the discussion if need be. So thank you very much indeed.
Thank you, Ian. A very interesting presentation. We do have some immediate emergencies, possibility to do something to avoid disaster. And there is this point that you showing, these call it technical methods to cool the Earth, extremely interesting, and I think even probably effective. But then we have to take into account also that we are people. We need to agree somehow that this is the thing we want to do, and we must not forget the south of the world, which will be the most affected by climate change, better said, by global warming, and we need to hear from them, and I hope that Shaden will be able to tell us something on this subject. Thank you, Shaden. Please.
You're muted.
Shaden, your microphone is mute.
Okay.
Okay.
Yes. Fine. Did you hear me now? It's good.
Yes.
It's better. You
Yes.
can see my okay. Fine. I will try to put it in full screen. At all we can do like this. So thank you so much to invite me to be with you in this very interesting discussion about our future and about this subject regarding the human security and how all of us could look about the future, our common future, because I think that the Earth is for all and there is no border between us. Just to present myself, I'm Shaden Diab. I have a chemical engineer. I worked from Paris, and I have a PhD in environmental sciences. I work about these issues related to the using green innovation since in France, in Paris, to depollute a very industrial site in the north of France, Metal Europe, in 2000, and it was an in the beginning, that is, we speak how we can use innovation and to interact with nature. In order to say that I can hear this discussion because also me, I'm a scientific, and I have the opportunity to discuss with politics during the COP, from a COP to COP. I can read all these some questions from participants and say, yes, no one is listening. What happened? We have the solution. Yes, today we have all solution, but the problem is now we can work alone, the politic or the scientist or the NGO or the activist, how things could do. For that, in 2016, I launched something which is called Green Education Program, to go to everywhere where are the new generation children, to speak with them about the issue related to to raise the awareness about the green educations and how we can interact with environmental policy. With the in the media, in the conference, in order also to introduce these green innovation to people. What I can see here, that's mean I think that is our new common challenge is the climate change. It is also a safety problem. It is also a human security for the future. We can see that today why we do this choice. I read some observations and questions that is for you, and I say the people that how we make the decision, how politics make the decision. It is for the economy, and also me as like a citizen from Europe or citizen from the southern country, is I do this decision because it's like an habitant or the logic, or like just a tradition. I just follow all the people. When I want to speak about climate change now in this geopolitical situation in Europe or in the southern country, where this is, I'm really interested in that. And it is my priority today, how the food security could be for this future generation that we are suffering, from a lot of pressure and prices, inflation, and energy crisis. So we could not, they are the same subject. We could not speak about science, and in the same time, we could not speak that because this solution, they are done for human being. They are done to be used for them. The question is that if we can say that is the climate crisis or today is for all people is really a reality, is the same vision from the north to the south, and is the reason it is like a consequence of a human action. We speak a lot from a long time and about to the energy transition in Europe, in all the world, to use another way to produce energy, another way to consume. But as we are today in 2024, the reality that the number of energy dependency is really high. We facing now in Europe this problem related to energy. We facing in Europe now also in the world the problem related to food security. So also we have solution, and you are prestigious scientific give this solution. Why we are here today to discuss again and again about a solution. And what is really the humanity today for security? Because we announced that climate refugees would buy about 1-2 billion by 2025. Yes, this is a big problem. This is a big challenge for the displacement of population. We can see in the screen population come North Africa, from Sub-Saharan Africa, South Asia, and also from East Asia and Central Asia. This is a huge challenge that is we are facing for the future. So the problem that is today and for the future, that is we are if there is a possibility to, there is a problem to nature and to treat with the earth. Is really the earth is like there is a physics of healing. What that mean? That mean for me as a scientist, every action have an interaction, and there is a consequence. We speak about all these issues related to the nature is really act because of our action, and about the consequence about what we are treating with depletion of resources, with energy consuming, with this also conflict. So the problem that of Earth is what is happening in climate change is a consequence of our action. So the issue today that if we are look about the nature as it's act about our reaction, it is also give us a solution. You present the solution scientific. We are say that we have a nature-based solution and frugal innovation. We can inspire from nature to cool the climate by forestation, by also plantation, all of that. And the issue today, if we are working in that, because the earth also is express this big tension and show us that the cycle of carbon dioxide, if it will continue to this, the life on the earth will not be possible. This is we can see that the earth is act in real way to our actions. But if the solution they are from the nature, so what happened? Why until now we could not resolve this challenge? I think that is, if we are looking about the studies about a nature-based solution in PS and the climate change, and I can consider that all these solution we present during this debate is about, it is something could provide more than 30% and resolve mitigation needed. But what is the problem? Why we are not work on it? I think we have a lot of challenge. I don't want to enter in the details of this challenge, just to overview some of that. If you look about what happened in southern country, like in in Egypt, by example, we have been a very known architect who called Hassan Fathi, and we call him the earth architect. 50 years ago in Egypt, he speak about how we can build and maximize a passive cooling, natural ventilation, just by building and to adapt to the desert context, and to inspire from the local environment in order to build in another way and to design the city in another way. Another experience coming also from Mexico, that is from this city with its high problem related to thousands of tons of toxic gases and also thousands of tons of heavy metals. We can generate another way to adapt the city and to build a green wall. There was an experience with the Mexico City Via Verde project. The problem it was facing that is to the cost of construction, with a negligible evidence to show how the positive impact. we can go also to Indonesia and the problem related to the inundation. We face it in a lot of city. I have the chance to discuss with the mayor of Indonesia, of Surabaya, Indonesia city, and she told me she has, she began to work in order in local policy and to adapt another way for to the drainage channel, and to work about the system of urban planification. But it was expensive. She faces a lot of problem related to local policy, to the corruption, and also it was not profitable. So I think that is we have the solution. We have all the solution. We, from nature-based solution could, as I repeat, could resolve 30% of problem related to the climate mitigation. But why we stay here today? We have facing a lot of social, economic, and environmental challenges. We have a geopolitical problem, conflict. We need also to be supported to create like a policy locally. If you can look about and also economically, because we need investment and we need also money. And the problem is today if we can look about the carbon credit market, and this is a problem because for the southern country today we are facing for that, because we need more transparency, we need more technical advancement in this market, and the value of money also, because there is a problem of value of money, which is really devaluation of local market, because for the price of carbon. So I think this is today we also not to resolve a scientific problem, we related to the social and economical problem related to application to this technology. And the target building support a network of locally also to that. Yes. And at the end,
excuse me, if you can close, it will be very nice, because okay, thank you.
Yes, I closed with this photo from it is a refugees camp in the north of France. He wrote, if we follow your dream, the speech done by Ali, and they say if we not really resolve this challenge today for climate change, we will maybe stay for future generation and stay in this type of building. Thank you so much to hear me.
Thank you so much, Shaden, for reminding us that we have these problems with whatever we do will affect people, and will not affect everybody in the same way. So it's something that we have to think about, and it's a lot of food for thought. Now, we still have about 20 minutes or so, and we can use these 20 minutes for a question and answer session. And we already had 18 questions. So I'm sorry, I'm not sure we can deal with all of them. But let me tell you that we have a discussion group, an email discussion group, where several of the panelists and the people who intervene collect to discuss these matters. The group has this strange name, which is the Proud Holobionts. And if you don't know what is a holobiont, just know that every one of us is a holobiont. It's a definition given by Lynn Margulis. You know probably the name. She was one of the greatest minds of the 20th century, a biologist, co-discovered with James Lovelock of the concept of Gaia and ecosphere homeostasis. So we have lots of discussions in that group. If you like to participate, just write to me. You can find my email on the questions on the sidebar, and so we can do that. And now let's try to answer at least a few of the questions. So the first question, which I'm not sure who can answer it, but Juan or Juan, I don't know where are you from, is if there are plants living on other plants would it be possible in the future to plant edible plants on trees? I'm not sure. I think the greatest expert that we have on this group in this group about forests and plants is Anastasia. What do you think, Anastasia?
Actually, I think that for 9 billion people, in this case, there would be too many parasites for trees. If we grow food as parasites on trees, but if we somehow like diminish our demands, then we wouldn't need these parasites either, because we could then grow our food in a more traditional way. So basically, we need, as Ugo, you mentioned, holobionts. One of the key concepts is the threshold of stability. If you go above this threshold while disturbing the system, then whatever you do, the system will be destroyed. So we just need to go below the threshold, not just in terms of polluting the environment, but also in how we directly interfere in what ecosystems are doing. So just in many cases, leaving them alone would be a great solution.
Okay, thank you, Anastasia. Then we have a question, not really a question, but a statement by Thomas Gradek. And he says, well, if you can reduce the atmospheric water vapor concentration, can we cool the Earth? And this is a question I'm sure is for Anastasia, absolutely. Can you see this question? It is the question and answer panel.
I'm trying to see this question. This is the next one.
The next one, yes.
Oh, about the Mediterranean. Well, so, but I don't understand what the question is.
It says, Mr. Gradek says, well, we, at the end, reducing the last paragraph, reducing atmospheric water vapor concentration will impact diurnal temperatures.
You know that actually reducing the water vapor concentration is not a good thing, because moisture transport, which feeds all plant life on land, depends on this concentration. And you might be interested in reading our recent study on this topic. You actually do need a certain sufficiently high concentration of water vapor for there to be condensation and also moisture convergence. So if we would be just drying out the atmosphere, so the plant life on land would suffer. But it is not a good strategy.
I think
Ugo,
that's a good point.
I have a
Yes.
comment. There
Sure.
is modeling going on right now via places like IASA and others that are actually going to be able to map the most probable locations of different ecosystems under climate change. In doing that, there's a lot of adaptive methods possible to change the demands of different kinds of agriculture. So there's a lot of work on that, too much to go into right now. But the fact is that already there has been a lot of crop migration, as well as going to xerophytic forms of agriculture. So we have adaptive methods. They do not necessarily, however, help a great deal in carbon sequestration.
Thank you very much, Ted. And if you like to intervene, you have a button at the lower part of the screen where you can raise your hand like this, with a little hand, and so you can do that. Anyway, next question from Killian O'Brien. Professor Dunlop, how fast cooling can occur? That's a difficult question, I think. Can you try to answer, Ryan?
Yeah, look, it is very difficult. I mean, you're not going to suddenly get from where we are today, I think 421 or 2 CO2 down to 260 overnight. Obviously, this is going to take time. A lot will depend on the way it happens, the speed with which I think the reduction takes place. But I think the practical side to this is we really do have to move to get both emissions down and reduce carbon concentrations in the atmosphere as quickly as we can. I think there has been modeling done how fast it might occur. I haven't got the answer to that at my fingertips at the moment, but I can probably find a couple of references for it.
And let me add that the problem is not so much what would happen if we get back to 260 ppm, but how to get there, because carbon capture and sequestration is an enormous task, and it will take decades if we are lucky. Anyway.
Well, I think that, I mean, the point is that you've really got to accept that there is a high degree of urgency, which frankly our leaders don't. People do not understand that this is the problem we're now facing.
Okay, then we have another question. Do we have a coral mapping tool? I think this would go, excuse me, to Anitra. Anitra, can you answer this question? Coral mapping? Anitra, are you there? No, I think she's not there. Ted, can you answer for Anitra?
Yeah, I've been doing some work with her on corals, and yes, there are some very good maps. Time series for corals, certainly for places like Australia. Ask Ian, he lives and others, where there's very good time series data on major coral formations. Not so great in the South Pacific, but and certainly around the Caribbean. So they do have time series. The actual state of them depends a lot on where they are. The closer they are to a developed place where a lot of tourism, fisheries happen, the more likely they are to have decent data. If you put a question specifically, I'm sure Anitra, because she's been gathering them for some work we're doing on carbon sequestration with seagrass and the stuff that she told you about. We're gathering further data on that for stuff to be done in Southeast Asia. So I'm sure she can respond to your questions more specifically than I can.
Okay. And then another question about photosynthesis. And if we screen the sun, we will have, there is no doubt that we will reduce the photosynthesis rate. But maybe I can comment on that because photosynthesis is a very complex story. It's really very, very complicated. And light, the availability of light is very important, but it's just one of the parameters which we have to take into account. In the end, what we are interested in is the yield of a certain plot, of a certain field. And in the way I understand it, it is not so critical. What we can do by shielding the planet from light over, Ian, how much would that be? A few percent, right? I think it would be 2%. I read it somewhere. It will not change the yield of agriculture, I think. Ian, can you comment?
Sorry, I missed that. You.
Yeah, they're asking. Mr. Dahl is asking if shielding sunlight will reduce the efficiency of photosynthesis. What kind of shielding we're discussing about? How much?
Well, in terms of the sort of techniques I was talking about, I mean, it depends very much on how you do it. Whether you're going to just look at it in a relatively limited sense in certain parts of the world on certain parts of the year, or you're going to try and do it in a much broader sense. I mean, there is research work that indicates that if you apply this in the tropics, it spreads quite readily globally. If you apply it elsewhere than the tropics, then it isn't quite happening. So again, I don't think we really know in the sort of marine cloud brightening type stuff I'm talking about exactly how that would play out. I mean, this is one of the problems of these types of things. We need to do the experiments to understand what the full flow through might be, and we don't have very much time to do it. So hence the need to get on with the task of the research as quickly as we can.
Okay, good point. And it's because we will not screen everywhere the same, I understand, right?
Yeah, well, that's the point, right?
Yes, exactly. So I think it is not the worst problem we have, right? But right, also this problem. And then Anna Kirilenko and precautionary principle. What risk do we see? Well, there are plenty of risks. Depends which method we use. My opinion is that if we use natural geoengineering, we would not change things so much, because what we're doing is just returning the planet to what it used to be before humans started tampering with climate. They have been doing that for maybe 10,000 years, but recently the tampering has been very heavy. The main problem that I see, and maybe Anastasia or Ian can tell us better than that we risk to affect the precipitation regime. So the rains, we do whatever we do, something changes. And the ecosystem is a good example of that good principle in biology that says that you cannot do just one thing. You cool the planet, okay, you may be able to do that, but lots of things happen. Just to make you an example, that you could think that greening the Sahara desert is a good idea because you collect a lot of carbon, you sequester from the atmosphere a lot of carbon, and you cool the planet. So it looks wonderful. What's the problem? We just green the Sahara, and then you discover, reading around, that the Amazon forest, the rainforest, gets a lot of minerals it needs from sand from the Sahara Desert. And you see that it's a great example that you may green the Sahara and dry the Amazon, which is not a good idea, or maybe we need to do what we are doing, but it's not easy because the system is extremely complex, and Anna is clearly putting a problem, mentioning a big problem. We are in trouble, and I tend to say that we are in the condition of a man or a person who is inside a building on fire, and you have to decide whether to jump out of the window and hope that you follow something soft, or you stay in the building hoping that the fire extinguishes itself. It's a difficult choice. So that's what I can say. Sorry, do you have comments, colleagues?
May just a brief comment.
Sure.
Just my personal
You
view.
have a hand button, Anastasia.
Ah, yes, sir.
That's okay. Don't worry.
My personal view is that the importance of Sahara dust for the Amazon is grossly overestimated, because it was like look like a great message, something depends on something, but this is all like.
Okay, that's great, Anastasia.
Yeah, sorry.
Anastasia, as usual, you know much more than me. It's always like this.
Sorry, I just couldn't resist making
I know. Anastasia, we know each other very well, and you know that I know that you know more than me in almost every possible field. Ian.
Yeah, look, I think none of these things are easy. I mean, the fact is we've spent 50 years and achieved precisely nothing in terms of the things that really matter, which is to get carbon emissions down and to keep the atmospheric carbon concentrations at a reasonable level. Now, I mean, the beauty of, I think, trying to have a geoengineering approach which is as close to natural as possible is that it does allow you, we think, to reverse the process quickly if you have to, if you see something happening that nobody's thought about. So, I mean, the law of unintended consequences is going to be running right the way through all of this stuff from now on. And I think in terms of the, the question of the precautionary principle, we should have been applying it years and years ago. We chose not to do so. And it's quite clear that our leaders still haven't got the slightest idea what that really means. I mean, the fact is we've got conflicts all around the world. These are adding immeasurably to carbon emissions, diverting attention from addressing these massive problems, both in terms of political attention, resources, and so on. And we are gaily sort of heading on, continuing to do that. So somehow we have to get a new conversation going, bringing this back to some sort of reality.
Okay, thank you, Ian. There is another question which I think is for you from Killian O'Brien. What scale of such systems? I mean, I think it refers to you. And can you estimate the cost of a blue cooling initiative that would be effective?
Well, I mean, that work is in train at the moment. I mean, we've got sort of budgets of, in doing research and putting it all together as a, 200 million euro, this sort of thing. But to do this work properly is going to take vastly more amount of money than that. And it'll depend on very much on how you do it. I mean, whether you find you can apply this sort of thing in a extremely broad context around the world, or it needs to be highly selective, like trying to pick particular areas of the world you need to pay attention to in times of high heat stress, for example, or not. Now, I mean, that is really up for grabs at this point in time. I don't think we haven't really pinned it down. There's a lot of thinking and a lot of research going into aspects of that at the present moment, but it just reflects, I think, the sort of early stage of this type of research work and the lack of acceptance historically of actually doing it. And people have talked of doing this for a long time, but it's been very hard to get the resources marshaled to get in behind it. As we're finding out in other things in climate, I mean, effectively finance to get changes being made around the world continues to be a major problem.
Okay, thank you. I think we have just a few more minutes, so I'm sorry. I apologize with all of you who asked questions. We have no possibilities to answer all of them. So I would just finish this with a question that we got from our host, Nebojsa, and about, we asked it to Shaden. What do you think would be the governance problems if we were to apply, to decide, to implement these ideas especially in the south of the world?
I think that the problem today is not the solution. We have all the solution, but we also need to have a philosophy. That means we need to have philosophy of decision maker, and they can work together in order to do the implementation of this policy. The problem today of the investment is the high investment for a macro project. We don't want to look about the local project experience was very successful and scale up this experience. So the problem today is that we should work together in international scale and not just to work country by country, and to do like a capacity building also, and to make it more economically possible for this country. I just want to underline the problem of carbon market. This is a big problem. In Europe, the carbon credit now market is open because for all these solutions, we make it economic. But when you look about the value of the money in the local market, is just they want to sell them for a centime. And for Europe, it's for 100 euro. So, you know, the problem is we just all the time go in the same mindset. Just to sell this idea, but we could not adapt to the local context.
Thank you, Shaden Nebojsa. Would you like to conclude?
Okay, we have to conclude the session, the webinar. First of all, I would like to thank all the panelists. It was very, very interesting event. And I would like to underline that there is a page on the WAAS website on the webinar, and it will be broadened. We should include in a week or two the presentations of the panelists, and in a way rearrange the whole page. And I'm inviting all the participants to follow this. There will be more information on the subject on the WAAS website in, let me say, 2 weeks or so. Once again, thank you very much. And thank you very much, Ugo, to you. First of all, you were the main organizer of all this.
Thank you to you, Nebojsa. Thank you, everybody. I would like to take the occasion to thank our ancestors who give us the possibility to be here, all of us, and to remind you that we have a responsibility to our descendants, and we always try to do our best. Thank you, everybody.
Thank you.